Ramanujan number it is called. So this 1729, he actually was traveling in a taxi. Who?
Sir, G.H. Hardy.
Englishman was a famous mathematician. He came in a taxi, and suddenly when he was talking to Ramanujan, Ramanujan said that you are traveling in a taxi number 1729. It's a very interesting number. So Professor Hardy was saying, what's so interesting about this number? So he said that 1729 is the smallest number that can be expressed as the sum of two cubes. For example, he said that 12 cube plus 1 cube. 12 cube is 1728 plus 1 is 1729. Or we can say it is the sum of 10 cube plus 9 cube. That is 1000 plus 729. So he was astonished that in such a short time, he just calculated all this in his mind and said that 1729 is the smallest number which can be expressed as the sum of two cubes. And since then, it is called as the Hardy-Ramanujan number. Okay, so this can come as a 1 mark question, that which is the Hardy-Ramanujan number. So they can give you 4 options. So you should know that 1729 is the smallest Hardy-Ramanujan number that can be expressed as the sum of cubes of.
Sir, why it is called Hardy?
Yeah.
Because it was discovered by them.
Sir, why it is called Hardy?
Because
it is written Hardy.
Hardy was actually Ramanujan's teacher. He was his professor. So he helped him in doing more research on numbers like these. Okay, Ramanujan made a discovery like this. So this was only one number. So he guided him further when he went to Oxford or Cambridge. I'm not very sure, but he went to one of these places. So this British man, he helped him to do more research. Okay, so that is why his name also came, because there was a discussion between those. It was a mutual discovery. It was not that Ramanujan said. And then obviously this is only part of the story. Then they went on to develop many theories, which you can read further. Okay, so when we are dealing with cubes, just like we have perfect squares, we also have a concept called the perfect cubes, right? So a perfect cubes are what? A number which can be expressed as the product of three numbers multiplied by itself. Square was a number multiplied by itself twice. So 4 was a perfect square. But when we talk about cubes, 4 is not a perfect square, is it? Perfect cube. So the smallest perfect cube is 1 itself, right? This is the smallest perfect cube, 1 into 1 into 1. Then the next one is 2 into 2 into 2, 2 into 2 into 2. So what is that? The total number of how many cubes will you find here? Can you tell me how many cubes are there in this? How many cubes? 8, correct. So 1, 2, 3, 4 plus 4, 8. So 8 is a perfect cube, right? If you look at a 3 by 3 Rubik's, how many cubes are there in this?
9.
3, 6, 9.
And 27.
So here 9 on here, 9 plus 9 plus 9. So 9 here, 9 here, 9 here. So that is 27. So these are called perfect cubes. So it's 27. So we have, just like we had the squares, you made a project also, and in the copy also you did squares of 1 to 25, right? So same way now,
Yes.
we will do the cubes of numbers from 1 to 20 at least. Okay. I hope you remember the squares of 1 to 25. If it is not learned, please learn it up because they are useful. Same way we are going to learn cubes now, and same way you will have to do the project also, just like we did for squares. For the half yearly, you will have to do a project on cubes. That means you have to make the chart on cubes 1 to 20, and again using Sikkim art you are going to decorate the border and submit it in that practical or the activity which is in the teams. So 1 and 2 together you will upload there. Okay. So how are we going to do it? This is our table that is given. You can note down this table. So here we have this table here starting from 1. 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is, how much is 5 cube?
125.
125, 6 cube?
226.
226. No, 6 cube?
216.
216, correct. 7 cube? Try out 7 cube.
343.
343.
43.
Everybody agrees?
Yes, sir.
Yes. 7
Yes.
into 7 is 49. 49 into 7 you will have to multiply. So that will give you 343. So fill that there. 7 cube 343. 8 cube. Anyone know?
512.
512.
12.
Correct. 512. 9 cube.
729.
729. 10 cube is 1000.
1000.
So it must have done in the classes also. And 11, this you might not have done in the lower classes. So we'll do 11 cube 1331, 12 cube 175, 13 cube 2197, 14 cube. So what you do is on your first page of the notebook, I'm just giving you 4-5 minutes. You are going to make a column number and second column will be cubes. And you will make the column from 1 to 20. It is better that you memorize this 1 to 20 because otherwise in some question you will be wasting time. What is 16 cube? Immediately you should know that it is 4096. 17 cube 4913. So this saves a lot of time. And the same thing we are going to do in the project. So kindly just note down this. I'm giving you 2-3 minutes. Just note down this.
Sir, do
on
we
it.
have a definition? A
Yeah.
definition. Any definitions? Sir,
Definition is cube multiplying a number by itself 3 times. Cube is multiplying a number by itself 3 times. Just like square was multiplying a number by itself, this is multiplying a number by itself 3 times. So 1 cube is 1 into 1 into 1.
So sir,
Two
while
cube
taking out
is-
cube root, so we will make the
Make
groups of
groups
3.
3. Yes, yes.
Yes, sir.
Excuse me, sir.
Anji,
Sir, in the last chapter, sir, there
Hmm.
was a pattern, sir, that
Uh-huh.
in squares of numbers they
Hmm.
increase by 1, then 3, then 5, then 7, then 9 from each
Ah,
other. So,
yeah.
sir, is in cubes also there is a pattern.
Hmm. No. For cubes there is no pattern. No.
Okay, sir.
It is irregular. It is irregular.
Yeah. Please note down from 1 to 20. I'm just giving you 3 minutes. You can note down. It's also in your textbook. This is actually your textbook page only. Here they are given as table 1 and table 2. You need not bifurcate it. You can make one single table from 1 to 20.
Sir, if we want to bifurcate it, can you bifurcate?
If you want, yeah, you can do. That's okay.
Sir, my phone's battery
Finish
is
the
very...
first.
Yes, no, sir, my phone's battery is very low and I'm not sitting at home. I'm sitting at my father's office. So, sir, I am...
You don't have a charger.
Yes, sir, my internet connection is also slow, so I am leaving the meeting.
Okay.
So, sir, will
When
you not...
I am recording the meeting. Recording the meeting. You
But, sir, my attendance will go.
no attendance. I will note.
So, I will note, na? Promise?
Hmm.
Okay, thank you, sir. Bye, sir. I'm leaving the meeting.
Okay, okay. Table 1 completed. Those who completed table 1 can continue with the table 2.
Sir, written table 2 also.
Okay, just give 2 minutes. Let others also complete.
Sir, done. Table 2 also.
Yeah. We'll wait for 1 more minute so that others can also complete. Somebody's mic is on. Those who are still not finished, hurry up. I'm just going to start the next thing then. Okay. For those who have not still finished, can note down from the book.
Excuse me, sir.
Yes.
Sir, do you have to submit the cube activity that you said before the PT2 exams?
Now, what is the date given for submission for the practical? Have you seen on Teams? That date, one date must be given. Let me check. There is a date given for submission, no? Have you checked that?
Yes, sir. Sir, which integration activity?
Yeah.
Sir, I have done and submitted.
Yeah.
Sir,
So now,
the square one has passed day before yesterday.
okay. Okay. So that's okay then. Those who haven't done
Sir,
can submit it still.
Sir, I have done and submitted also.
Ah, good. So now what you need to
Sir,
do
I
is,
Excuse me, sir.
yes.
Sir, there was a integration activity that you said that was of cubes, making 1 to 25 cubes. Sir, the link is also sent for
No,
square.
first one was squares.
First
Second
was
one is
square.
cube.
Yes.
Yeah. First one was square. Second one is cube. Now cube I have just started, so you can start doing the cube one. So what you need to do is just like you did for squares, you need to write down 1 cube is 1, 2 cube is 8, maybe up to 10 you can do on one side. Okay, and then 11 cube is 1331 up to 20 cube, right? And this you can make on an again on an A4 sheet. Okay, and whatever is the border that you are having, that border should be done integrated with Sigma. So this part you have to design, and this middle part also you can design. So all that creativity you can do as you did for the first one. First one, same way for, you can write cubes heading of numbers from 1 to 20.
Excuse me,
And
sir?
please write your name here. Please write your name before submitting. Name, class, and section you have to write. Some are submitting there, but it's okay. But it's better that you write your name and submit. Yes.
Sir, do we have to take the same Sikkim or a different one?
Any Sikkim are not the same. You can find out more for yourself. But it has to be related to Sikkim. That's important. Okay. You need not paste the same design. Try to create another design, because you are doing only one activity per PT. So one PT for PT1 you have already done squares, and now for half PT2 you will be doing cube. Now the next one we will be doing only after the half yearly exams in September only. Okay, this is clear. This activity how it has to be done, and then you will have to submit this by let's say today. Maybe by 3rd week of August, 23rd August, I'll put the date. I'll put in the assignment column 1 space to upload. Okay. Understood? Shall we go on further?
Yes, excuse me, sir. Excuse me, sir.
Yes. Ask.
Sir, in the assignment where we have to submit the work of chapter 5, 6, 7, do we have to do the exercises or the examples?
Exercises, so we are doing in the class. You are supposed to do in the classwork copy.
Yes,
exercises. Sir. Why you want to do that again in the homework copy?
Okay, sir. Because I thought there are already solutions for the examples. So.
There are already solutions, but the thing is that we are not discussing in the class because it is solved. So it is your duty to solve, to see those examples, understand how it is done, and then note it in the homework copy. Otherwise, in PT1, what did I see? That you are doing only the questions that we discuss in the class. That is the unsolved ones. You are not going through the solved example. So any question that is asked from solved example, many are not able to do.
Okay, sir.
Yeah. Excuse me, sir?
Yes.
Sir, in the solved examples, the answers are given. So can we do with our own solution that you have taught it, because some solutions are different from your solution in the book?
Yeah, you can do by your own methods. The only thing is that answer should come. You cannot do by a different method and get a different answer. Method, but please make sure that the answers are matching.
Okay, thank you, sir.
Okay, now we start with the first question. Which of the following numbers are not perfect cubes? Now this becomes an easy chapter because you have already done square roots. So just like we did for square roots, the prime factorization, instead of making groups of 2, now you will be making groups of 3. So 216, you are doing the prime factorization of that. So 2 goes 108, 2 goes 54, 2, 27, 3, 9, 3, 3, like that. So what happens? This is a group of 3 and this is a group of 3. So is it a perfect cube? Is it a perfect cube? Yes.
Yes, sir.
Whenever you are able to make a group of 3, then that is called a perfect cube. So 216 is a perfect cube because we are able to make groups of 3. No number is left. So conclusion, it is a perfect cube. Okay, so you can start doing the first one. 216, make the factors and make the conclusion that it is a perfect cube based on the observation that you are able to make groups of 3. And those who have done the first part may try the second part also. They can keep on doing the parts as you do. Okay, first you try the first part, and it's going to be easy because you have already done squares and square roots. So this is just like that. There we were making groups of 2. Now you will make groups of 3. That's it. Yes, done the first part, then do the second part.
Sir, done.
Okay, so once you've done the first part, second part when you do, you will realize that it is not a perfect cube. The reason is when you do with the 128, are you able to form groups of 3? You are not able to make groups of 3. So here you see what is happening when you do with 128. You are getting 2, 2, 2, 2, 2, all 2s. But when you are trying to make groups, this is a group of 3, this is a group of 3, but this 2 is alone. Okay, this 2 is left without making a group of 3. So conclusion, 128 is not a perfect cube. Okay, note down the second, and those who have done the second can try the third, that is 1000. Somebody's mic is on, just switch it off. Yes. So when you're doing 1000, what do we realize? Are we getting a perfect cube? Are we getting perfect cube?
Sir,
Is
wait.
1000?
Yes, sir. Yes, sir. Yes, sir. 5, 10.
Yeah,
Sir, wait.
fine. So 1000, we are starting with 2.
Sir, can you scroll up?
Up, okay. Those who have done 128 can try 1000.
Sir, what is the next
Yes, sir, done.
1000?
Yeah, after 1000 we have 100. So in 1000, what are we observing? In 1000, are we able to do it? We are able to make groups of 3, right? This is a group of 3 here. This is a group of 3 here. So 1000 is a perfect cube. 1000 is a perfect cube, right? The next one is, those who have done 1000 will try 100. Those who have done 100 will try the last one, that is 46656, isn't it? That's the last part. Yeah. So 5 parts are there. So those who have done 1000, please try 100. Is 100 a perfect cube? We know that 100 is a perfect square, but is it a perfect cube? The answer is no. It's not a perfect cube. Why? Because there are only groups of 2 being formed. So it is not a perfect cube. And then you can try the last part, 46656. Finished 1100. So then you will do 46656. Now look at 4556. Is that perfect cube? Let us see. Look at 46656. 1 minute. Yeah.
Sir,
Yeah.
can you wait on the 100th one?
Yeah. Okay. Do. So here we are able to make groups of 3. So this is a perfect cube. So quite easy, right? If once you have understood the concept of square roots and squares, then this is just an application. Instead of making groups of 2, we are making groups of 3.